The fifth example in the series maximizes an area. You are watching differential calculus. The fifth problem includes a print area of 24 square inches, and the book margins at the top and bottom are 1.5 inches, while that of the sides are 1 inch. We are to look for the economical dimensions of the page. So starting with the print area of 24 square inches, we can let x be the width of the print and y for the depth. The first equation is then translated as the area of the print is equal to the width times depth, xy. From this function, take y as equal to a over x. And since the area of the print is constant at 24 square inches, y is then 24 over x. To take the dimensions of the page, we also use the area. The premise provides side margins of 1 inch and top and bottom margins of 1.5 inches. The paper width is then x plus 2, and its depth is y plus 3. This time, the area of the paper is then computed as x plus 2 times y plus 3. So substituting y, or 24 upon x, into the function, we get the area of the paper as x plus 2 times 24 over x plus 3. Take the LCD of the second term, which is x, and transform the whole term into 24 plus 3x. This is multiplied to the other binomial to have 24x plus 3x squared plus 48 plus 6x all upon x. Collect similar terms and have 3x squared plus 30x plus 48 all over x. Now simplify each term by dividing everything by x to get 3x plus 30 plus 48 over x. Place the denominator on top by using its reciprocal. So the area of the paper is then 3x plus 30 plus 48x raised to negative 1. Having the simplified function, we can then differentiate it. dA over dx is 3 times the derivative of x plus the derivative of 30 plus 48 times the derivative of x raised to 1. dx over dx is 1, and the derivative of a constant is 0. Thus, dA upon dx is 3 plus 48 times the derivative of x raised to negative 1, which is negative 1 multiplied by x raised to negative 2, with chain rules dx over dx, which eventually is taken as 1. So dA over dx is 3 minus 48 over x squared. Maximize the area so it becomes 0, equated to 3x squared minus 48 over x squared. Cross-multiply the denominator, generating 3x squared minus 48 as equal to 0. Transpose one term to the other side and have 3x squared as equal to 48. Divide both terms by 3 and get x squared as 16, or that makes x as 4. Also solve for y from the first equation, or that is 24 as equated to 4y. So y is then solved as 6 inches. Knowing the print dimensions, we can then take the paper width from x plus 2. That is 4 plus 2, making 6 inches. The paper depth is also derived as y plus 3. Placing 6 for y, we get 6 plus 3, which is equal to 9 inches. So the page's dimensions are 6 by 9 inches.